Find the solution set of the following linear inequations graphically. Okay, let us begin. Now first what we'll do, we'll consider the xy coordinate plane and let's try to understand what's the meaning of x greater than equals to 0 and y greater than equals to 0 mean. So let's try to understand first what's the meaning of x greater than or equals to 0. For this we're going to convert the inequation into an equation. All we have to do is replace the inequality symbol greater than or equals to with an equals to symbol. And that means we have x equals to 0. Now what does x equals to 0 represent? This is simply the y-axis. Now this y-axis divides the xy plane into two regions. The one region is going to lie to the left of the y-axis, we're going to call it 1, and the other region is going to lie to the right of the y-axis, which is region 2. So x greater than or equals to 0 means we have to consider all the values of x that is picked up from region number 2. That means all the positive values of x we have to pick up. Okay. Similarly, when we talk about y greater than or equals to 0, first we'll write it in the form of an equation. So we have y equals to 0. So that talks about the x-axis. Now if we consider y greater than or equals to 0, so here we have to consider all the positive values of y. Now as we can see, in the first quadrant, the both of the two shaded regions are intersecting with each other. So in a way we can say the first quadrant is going to be the region that is common to both x greater than equals to 0 and y greater than or equals to 0. So that's what it means. Whenever we have these two conditions given to us, this simply talks about the first quadrant. Okay, now we'll come to the actual problem. So here we have two inequalities. So we have the inequality x plus y greater than or equals to 9, and we have the other inequality 3x plus y greater than or equals to 12. Our first task will be to convert them into an equation. So we'll consider x plus y equals to 9. All we have done is replace the inequality symbol greater than or equals to with an equality symbol. Next what we'll do, we're going to consider 2 points. So let's say for the first point, if we choose the x value to be equals to 0, then the corresponding y value comes out to be equals to 9. So this is going to give us the point 0, 9. Then if we consider the y value to be equals to 0, then the corresponding x value comes out to be equals to 9. So that means in this case, we have the other point 9, 0. Now using these 2 points, what we'll do, we'll plot them on the xy plane and then join them with the help of a straight line, and that is going to give us the graph of the linear equation x plus y equals to 9. As we can observe here, the line x plus y equals to 9, it passes through the point 0, 9 and 9, 0. It divides the xy plane into two regions. One, let's call them region number 1 and 2. Now region number 1 lies above the line and region number 2 lies below the line. Of the two regions, there is going to be only one region that satisfies the inequality x plus y greater than or equals to 9. Now we need to verify which particular region is that. So now what we'll do, we're going to consider a point on the xy plane, and for simplicity purpose, we're going to consider the origin 0, 0. So let's say at the origin 0, 0, we will check if the inequality is true or not. So we have 0 added to 0 greater than or equals to 9, which gives us that 0 is greater than 9. Now we know the 0 is not greater than 9. This is an incorrect statement. This only means that the region number 2, which contains the point 0, 0, this is not going to be a part of the solution for the inequality x plus y greater than or equals to 9. We only have to consider region number 1. So that means any point that we pick up from region number 1 is going to satisfy the inequality x plus y greater than or equals to 9. Now we come to the next inequality. We have 3x plus y greater than or equals to 12. Now here we will be again sketching the graph of 3x plus y greater than or equals to 12. For this, we have to first convert it into an equation. We have 3x plus y equals to 12. We're going to consider the point when x equals to 0, y corresponds to 12. And then when y equals to 0, then x will be 4. So we have these 2 points, 0, 12 and 4, 0. Through these points, we have the line 3x plus y equals to 12 passing. Now that we have the line 3x plus y equals to 12, we see that the yellow line also divides the xy plane into two regions. One region will be to the left of the line and the other region will be to the right of the line. So let's consider the origin point 0, 0. So here at the point O, which is 0 comma 0, our inequality is going to give us 0 greater than or equals to 12. This is also an incorrect statement, which means that the region containing 0 comma 0 is not going to satisfy the inequality 3x plus y greater than or equals to 12. So we have to consider only the region lying to the right of 3x plus y equals to 12. Okay, then we have already mentioned that we are in the first quadrant, because in the first quadrant x is greater than or equals to 0 and y also greater than or equals to 0. Now we'll find out the region that is common to all the 4 inequalities. So while selecting the region, we have to make sure we are only in the first quadrant. So we will consider this region. So this is the region that contains solution. So it has to be above the x-axis, it has to lie to the right of the y-axis, and it has to be above each of the 2 lines. So this is going to be the common region. Any point that we pick up from this solution is going to be a solution to the linear inequality. So this is a region of solution. And clearly we can observe here that this is an unbounded solution. So we get an unbounded solution, that means solutions.